All right. Okay. So we learned that igneous rocks form when magma cools and solidifies. So we're going to move on and um, I'm going to read this, The Art of Making Stone Tools. Many prehistoric cultures made tools out of rocks. Scientists working in East Africa have found obsidian stone tools that are nearly 2 million years old. Obsidian was especially prized by ancient toolmakers. Obsidian breaks into pieces with sharp edges that are good for cutting and piercing. To make a very sharp cutting tool, ancient toolmakers struck a block of obsidian with another harder rock. This caused a long, thin blade of obsidian to flake off. Although the blade was fragile, it had incredibly sharp edges. In fact, the edges of obsidian blades are much sharper than metal scalpels used by surgeons today. Making a spear tip or arrowhead was more time-consuming. The toolmakers started with a relatively flat piece of obsidian. Okay, so they shaped it by striking off tiny flakes of rock, one after another, from the edges. They gradually shaped it into a sharp, durable, and often beautiful pointed tool. All right, that's pretty amazing. Okay. Why do you think obsidian was a prized material for ancient tool makers? I was amazed to find out that it's sharper than the scalpels that surgeons use today. All right, we're going to read page 56 and 57. Sedimentary rocks. These are my favorite rocks. I think they are beautiful. Sedimentary rock is the second major class of rocks. Sedimentary rocks are made of sediments. Sediments are tiny bits of rock and sand combined with fragments of once living things. And that's another reason. This is where you find fossils. And of course, I love fossils. Sediments are tiny bits of rock and, I already read that, sorry. Sediments collect in low-lying areas both on land and in bodies of water. They form layers one on top of the other. Over long periods of time, the weight of overlying layers compacts the sediments in deeper layers, squeezing them close together. Sediments also become cemented or glued together as dissolved minerals fill the spaces between the sediments. As the sediments dry, the dissolved minerals turn into solids, binding the sediments together. Over time, compacting and cementing processes transform sediments into sedimentary rocks. So that's how they form. Most sedimentary rocks are more easily broken than most igneous rocks. Hit a sedimentary rock with a hammer and it will crumble or break apart. Most sedimentary rocks contain fossils. Limestone is a sedimentary rock often packed with fossilized skeletons and shells of tiny ocean creatures. Some sedimentary rocks get their name from their sediments. Sandstone started as grains of sand, whereas mudstone formed from ancient mud. So, we've learned that fossils are filled in with minerals, that it's not the actual bone and stuff. And so that's part of the sedimentary rock process. You can see that on the picture that the eroded formations of these sedimentary rocks in Badlands National Park in South Dakota, some of you may have been there, show their distinct layers. And that is something I love, showing the layers in the rocks. The oldest layers, as we know, are on the bottom. Okay, page 58. No, that's where we're stopping, because then we're going to go to metamorphic rocks. Just 1 minute. I keep getting ahead of myself. I am supposed to read page 58. Okay, so metamorphic rocks. So we've learned about igneous rocks that come from lava, hard, and solidify. Sedimentary rocks, which are made of the sediments and the layers. Okay, so now we are moving on to metamorphic rocks. The third major class of rocks is metamorphic rock. Metamorphic rocks form when igneous or sedimentary rocks are exposed to extreme heat and pressure. They can even form from older metamorphic rocks. High temperatures and crushing pressure alter the minerals in the rocks. Mineral grains may be flattened or rearranged into layers, swirls, or stripes. They may also be changed into completely different minerals. They can totally change. Remember granite, the igneous rock? When granite is subjected to intense heat and pressure, it becomes a metamorphic rock called gneiss. When the sedimentary rock limestone is squeezed and heated deep below ground, it becomes a metamorphic rock called marble. And when we go to Lincoln, to the Capitol, there are marble columns that help hold up the Capitol. They're beautiful, and marble is used in a lot of buildings, in beautiful buildings. So we'll look at that, and we'll know that at one time it was limestone, but through heat and pressure, it became marble. Metamorphic rocks tend to form deep within Earth's crust. The pressure from countless tons of overlying rock is tremendous. Equally powerful is the heat rising up from hot magma in the mantle beneath the crust. Metamorphic rocks often form where tectonic plates are slowly colliding. They can also form as magma travels up through cracks in the Earth's crust and heats the rocks around the cracks. If the heat of the magma completely melts the rock again, then it becomes an igneous rock. If the rock is heated just enough to be changed, however, it instead becomes a metamorphic rock. And the cycle goes on and on. So let's review. Metamorphic rock forms when igneous, sedimentary, or older metamorphic rocks are exposed to extreme heat and pressure, and it changes the minerals, actually changes them in rocks. If you're thinking, what can you infer about when the first metamorphic rocks appeared on Earth compared to igneous and sedimentary rocks? Well, we infer, think from our brain what we know and what we got from the book. Most likely, metamorphic rocks came after the igneous and sedimentary rocks because they're made from those types. And the cycle goes on. That's so interesting, I think. Okay, what role do tectonic plates play in metamorphic rock formation? Well, we know that they're made where the tectonic plates are slowly colliding, bumping into each other. So the plate boundary serves an easy way to identify where metamorphic rocks form. That's pretty neat. Okay, and if you look at this picture, you can see the molten rock, the heat coming up, the metamorphic rock, and then the pressure from the top. It's pretty amazing. So remember, we've got igneous, sedimentary, and metamorphic. Okay, I'm going to read this page to you and then we'll stop and answer some questions. Agnes Nyahongo stone sculptures. Zimbabwean sculptor Agnes Nyahongo became interested in carving rock at an early age. Her father, Claude Nyahongo, was a sculptor. She worked in his studio as a young girl and learned how to cut and polish rock. She is now one of Zimbabwe's most well-known artists. Agnes Nyahongo carves many of her sculptures from a type of rock called serpentine. Serpentine is a metamorphic rock. The type of serpentine Agnes Nyahongo uses for many of her sculptures is very dark in color. She usually polishes only some parts of her sculptures, leaving the rest simply raw stone. I think it is just beautiful. All right, so now you need to stop and answer those questions, and then there will be another video.